Hi, this is Phil at Simply Rhino, and in this introductory level video tutorial I'm going to create a nighttime architectural interior render with V-Ray 6 for Rhino 7. V-Ray is an industry standard photorealistic renderer known for its accurate results and fast render times. It used to be the case that creating interior scenes required making significant changes to V-Ray's default settings. But this is no longer the case, and here I can show you how to create a render like this in just a few simple steps. I'll start by using the same model and daylight setup as in the previous architectural exterior tutorial, before adjusting the camera exposure and adding interior elements and materials. I'll then look at adding various lights into the scene before adjusting these and setting the exterior lighting to nighttime. Finally, I'll demonstrate how to use V-Ray Light Mix to make changes to the lighting after the render has completed. The starting point for this tutorial is the daytime exterior scene that I looked at in a previous video. If you haven't already seen this, there's a link to that video in the description below. By switching to the V-Ray interactive viewport, I can see that the scene is fairly bright and well illuminated, courtesy of the V-Ray sun and sky system. If I navigate to the Named Views panel, you can see that I've created and saved an interior view here. If I activate this view, then you can see that, despite the fact that the whole front of the building is clad in glass, the interior view is much darker and also the interactive view slows down somewhat. The reason for this is that only a limited amount of direct illumination from the sun and environmental illumination from the sky is making its way into the interior. So we're therefore much more reliant on indirect illumination. In other words, all the light that is bouncing around from surface to surface in our scene. Of course, one of the things I can do to increase the scene illumination is to adjust the camera exposure, and thereby let more light into the scene. If I open up the V-Ray Asset Editor and navigate to the camera settings, moving the exposure values slider towards the right, so lower numerical values, will increase the exposure. I'm going to choose a value here of 11. I'm now going to start to add a few components into the interior from the Cosmos browser. So I'm going to switch to a shaded mode to speed things up whilst I add those assets. I'm going to add some people and furniture, and in order to declutter the screen, I'm going to select just a couple of elements here: the glass partition, this partition wall, and the floor slab. Then I'll navigate to the Rhino Visibility tab, and I'm going to use Isolate here to show just the highlighted geometry. This will make it much easier on screen to see where I'm placing the new geometry. I'll open up the Chaos browser and I'll choose Furniture. And I want to choose a suitable sofa to sit against the glass partition. If I've already downloaded a component from the browser, it will have this blue tick next to it. And if I haven't, I'll see the download symbol here. So if I choose Sofa 6809 here and download the geometry, then I can bring this into my scene and place it in an arbitrary position. Finally, I can just manipulate it into position by using Rotate and Move. Next, I'll add the first person into the scene, and I'll go back to the Cosmos browser, search People, and choose Standing. I've already downloaded quite a few of these, so let's look at reusing a figure that I've already downloaded. And I'll choose Misha, and load her into the scene. Once again, I can position as previous. Assuming that I've finished adding content for now, I'll then need to restore all the scene geometry. So I can go to the Rhino Visibility tab and right-click on the Isolate icon to unisolate. Next, I'd like to look at adding some materials. So I now need to go back to the V-Ray interactive mode so I can see the effect of those materials. I want to apply a Pantone reference color to the partition wall here. And there are many web-based conversion sites where you can find RGB values for various commercial color swatches. From the V-Ray Asset Editor, I'll select the Material tab, and from the bottom of this pane, I'll create a new generic material. Then change the name of this in the browser to Pantone 535. I'll click on the small arrow on the right of the Asset Editor here to get to the settings for this material. And, by default, this will have a grey colour. If I click on the colour slot here, this will open the V-Ray Colour Picker and I'll switch the RGB range from 0 to 1 to 0 to 255 and then put in my RGB conversion values for Pantone 535. I then need to give this a little bit of reflectivity, so I'll move the reflection colour slider to the right to get a very pale grey, and then I'll move the reflection glossiness slider to a value just above 0.5 to create a fairly flat material. Finally, I can select the partition wall and apply the material to the selection. I now want to add a concrete material to the floor. And one of the things that may not have been clear in the two previous videos is that the V-Ray 6 material library is now part of Chaos Cosmos. If you've been using V-Ray 5, you may be used to a locally stored library accessed via the V-Ray Asset Editor. And a little later on, I'll show you how to restore this behavior. I'll switch to the V-Ray tab in Rhino and open up the Chaos Cosmos browser before navigating to Materials and then choosing Concrete. I'll scroll down and find Concrete Flooring H01 and download this, and then import that into my scene, and it will now appear here in the material list in the Asset Editor. I'll select the floor plate in Rhino and then from the Asset Editor right-click on the material and select Apply to Selection. The material will now update in the V-Ray interactive viewport, but at this stage the material won't be mapped to the correct scale. This material uses a tileable texture that has a 200 cm repeat, and the easiest way of mapping this to the floor is to use box mapping. All material mapping is carried out in Rhino, not through the V-Ray interface. And once again, I'll go to the Rhino Visibility tab and isolate the floor slab. I'll next use Zoom Extents in the top viewport so I can see all of the slab and then switch to a Rhino Rendered viewport mode. Now, in both the Rhino Rendered and V-Ray Interactive modes, it's very hard to see the material or indeed the floor plate itself because it's an isolated object with a reflective surface in a strongly lit scene. To make the material more visible, so that it can more easily be mapped, I can navigate to the Rhino Render tab, open up the Sun panel, and temporarily turn off the sun. I can now see the texture clearly in both the top viewport and the V-Ray Interactive viewport. I'll pick the floor plate and, because it's a fairly simple rectilinear object, I can use box mapping. So to do this, I'll go to Properties and then navigate to Texture Mapping and change the mapping from Surface to Box Mapping. I'll then be prompted to draw a mapping widget box and I'll set a value of 2000 for the length, and then to use the same value for the width and the height, I can just enter twice. I'll choose the Capped option. This will add the texture to the top and bottom of my notional box, and then I'll see the correctly scaled and tiled texture. I can then turn the sun back on again and go to the visibility toolbar and unisolate. And I'll wait a short while for the scene view to refresh. I mentioned earlier that the material library is now part of Chaos Cosmos. And whilst this may make it easier for Chaos to incrementally add to the material library, one could argue that this is less convenient when searching for and applying materials. If I open up the left-hand palette of the V-Ray Asset Editor, you'll see that this area is blank. If you had a V-Ray 5 installation and would like to return to the local library location, then you can do this. First, to check if you have an existing local library, go to the Windows File Explorer and navigate to the Documents folder. And if you had a V-Ray 5 installation, you should see a V-Ray Material Library folder that contains several subfolders. If I now go back to the V-Ray Asset Editor and click on the folder icon, I can navigate to Documents, V-Ray Material Library, AEC, Materials, V5.0, Materials, and Select Folder. I can now see the library from the Asset Editor, and, of course, I can add any new materials to this should I wish. A technique that can help to achieve a quick lighting setup is to override the materials. When the scene, as in this case, relies on indirect illumination, then there can often be colour bleed between the more intensely coloured materials, and also material reflectivity can confuse the issue of exposure. If there are complex finishes on the materials and blurry reflections, such as frosted glass and satin finished metals, then these can increase render times and therefore preview times. So, overriding the materials and removing these complexities can both speed up the scene previews and also make setting up the exposure and lighting more straightforward. I can turn on Material Override here from the Settings tab of the V-Ray Asset Editor, and this will replace all materials with a grey diffuse material. As the scene camera is inside the building and all materials are overridden, then there is no illumination in our scene, as the light source is outside the building. To remedy this, if I select the glass material here and uncheck Can Be Overridden, then you'll see that the illumination is now as previous and all the materials except the glass are the default grey colour. Next, I'm going to add some more interior content and materials before returning to add some internal illumination to the scene. So here's the same scene with the additional content, some of which has been modelled in Rhino especially for this scene, and the remainder imported from Chaos Cosmos. The lighting is the same as the previous scene, so now I'll look at adding some interior illumination. If I switch to the finished render, I'll point out the various V-Ray lights used in the scene and then switch back to Rhino to explain the setup of these. Here's the final daylight interior scene with all the internal lights turned on, and in order to describe the light types I've used here, I'll turn off all the internal lights and then introduce them one by one. The stairwell light is a V-Ray rectangular light that is concealed above the stairwell, and the spread of the illumination is controlled so that it only fills the stairway. The circular feature lights are V-Ray mesh lights. These are Rhino surfaces or meshes that we can convert into a light object. The illumination above the painting is created by V-Ray sphere lights, and the meeting room light is another V-Ray rectangular light, this time hidden behind the grille, which helps not only to diffuse the light but also to stop glare. The television screen isn't a light as such, and here I've used a V-Ray emissive material. Finally, there's another rectangular light used in the lower part of the stairwell, this one being quite subtle, and some further rectangular lights illuminating the more distant parts of the building. Going back to Rhino, I've put all of the new elements on their own separate layers. So if I go to the stairwell illumination layer and turn this on, then I can switch to the V-Ray interactive mode to see the effects of the light. If I now right-click on this layer and select Objects, I'll see the rectangular light highlighted in the top and front viewports, and turning off the trees layer will make this easier to see. The light is located inside the stairwell and about 1.5 meters above the ceiling. In the V-Ray Asset Editor, I've named the various lights, and I can see the properties of the light by clicking on the arrow on the right hand of the panel here. The intensity of the rectangular light is controlled by a numerical slider here, and the default value is 100. By default, the rectangular light uses a scalar value for the brightness, which means that the brightness is directly proportional to the surface area of the light. I can adjust the colour of the illumination here, and I'm going to warm this up slightly to make it look more natural. And I can also make the light invisible so the effect of the light can be seen but not the light itself. One setting that I want to make use of here is directionality. And if I move the slider to the right, higher numerical values, the light spread becomes narrower, enabling the light to be concentrated on the stairs only and thus avoiding creating a pool of light on the floor. The next object that I added was the circular light fittings, and these are created with a V-Ray mesh light. Now, there's a number of these circular lights in the scene, but they're all controlled with one V-Ray mesh light property, so they can be adjusted together. To show how I created these lights, I'm going to look at a simpler version of the scene. Here I have a box that represents our building, and the same circular light model positioned on the ceiling. If I go into the V-Ray interactive viewport, this shows that there is no illumination in the scene as yet. If I hide the box, our simplified building, I'll be left with just the geometry for the circular lights, a set of Rhino solids and surfaces. As usual, the objects are separated onto layers, and all the metalwork here has a chrome material applied. And, as yet, these circular trimmed surfaces here have no material applied. It's this circular surface that I want to make into a light. So, with the surface selected, I'll left-click on this icon here, Convert to Mesh Light, and if I open up the V-Ray Asset Editor, I'll see the light listed here. If I go back into my model space and select two different surfaces and Convert to Mesh Light, then those two surfaces will be controlled by a new Mesh Light parameter. So, selecting multiple objects at once applies a single light parameter to them. Finally, I'll select the remaining two circular surfaces and Convert to Mesh Light, so now I'll have three separate mesh lights in the Asset Editor. If I want to have just one mesh light controlling these 5 circular lights, then I'll first choose which light I want to use. I'll choose Mesh Light, and then if I go into Rhino's model space and select one circular surface, I can go to Properties and choose V-Ray. I can then change or choose which mesh light parameter is responsible for this surface. So I'll repeat this step for the other 4 circular surfaces. If I later want to break apart these instances, I can use the Make Unique button here. Once the 5 surfaces are all instanced, if I go back to the V-Ray Asset Editor, I'll see these unused lights. However, I can use this button here, Purge Unused Assets, to clean out the redundant mesh lights. I'll now rename the mesh light as Circular Feature Light. And if I go back to the perspective viewport, I'll show the box, our simplified room, and you can see the effect of these lights. The properties are a simplified version of what's available in the settings of the V-Ray rectangular light, and this time the default brightness level is set to 30. The next illumination I'd like to look at are the lights above the painting, so I'll turn on the layer for these lights. Here, again, I have a combination of Rhino geometry and V-Ray lights, but this time I'm using a V-Ray sphere light. These look very subtle at the moment, but they'll come into play more when I darken the exterior environment. As with the previous solution, I'm going to use a simpler version of the geometry to explain how these sphere lights are created. If I switch to a close-up view of the light fitting and switch to the V-Ray interactive mode, you'll see that the lights have a glass globe in which our bulb is going to be contained. And this bulb is modelled as a solid with a wall thickness of about 3 mm. To add the sphere light, I'll switch to the Rhino rendered viewport to speed up the display and also so I can see the point that I've used to reference the centre of the glass globe. I'll add the sphere light from the V-Ray toolbar here, snap to the centre point and then pull outwards to set the sphere light to an approximate size. If I now switch back to the V-Ray interactive mode, the effect of this light can be seen. The parameters and options for the sphere light are very similar to those of the rectangular light. To copy the sphere light to fill the other two glass globes, I'll select the light from the asset editor and then copy this in the Rhino top viewport, making use of the project constraint to ensure that I maintain the Z height when copying. When a V-Ray light is copied inside of Rhino, then it's automatically instanced and all three lights are controlled with the same V-Ray light parameters. Finally, if I just turn off the environmental lighting, you can see that these sphere lights are fairly subtle, like the rectangular lights, and that changing the brightness value allows for a very broad range of adjustment. The last light I'm going to look at in detail is the meeting room light, and this is a combination of some Rhino solid geometry and a V-Ray rectangular light. Looking at this in close-up, there's a rectangular frame and an egg crate style diffuser, both of which are modelled as solids and have a metallic material applied. There's a gap between the ceiling and this Rhino geometry, and slightly above the diffuser there's a V-Ray rectangular light. The settings for the light that I've used are shown here, and, as with the stairwell light, the directionality setting is important in casting the light over the target area. The V-Ray light and Rhino geometry behave in a physically correct manner, so the diffuser softens the light when viewed from an angle and prevents this from causing a glare in the camera. When we look at the scene as a whole, this light is important in not only lighting the table and the surrounding area, but also in establishing the strong contact shadows underneath the table and chairs. The glowing TV screen is created with an emissive material rather than a light as such. In front of the emissive TV panel, I have a clear glass screen, and in this respect, the emissive materials will behave in a physically correct manner, just like the lights, when surrounded with Rhino geometry. New emissive materials can be created by selecting Create Asset here and then navigating to Materials and selecting Emissive. If we look at the properties of the saved TV screen material, then perhaps the most obvious setting is Intensity. This has a default value of 1, and unlike lights, it's often the case that this value needs to be increased in a bright scene and decreased in a dark environment. The material colour here is overridden with an image, in this case a screen grab from a news programme, which has been mapped to the surface representing the screen with planar mapping. I've now added a few additional lights, including one at the bottom of the stairwell, which helps this area to read a little better, and some more rectangular lights in the distant part of the building, and these will come more into their own when I darken the environment. If I go to the Rhino Render tab and open up the Sun panel, I can move the time of day forwards, and as I do this, you'll see that the lighting changes in the interactive viewport. I can see the sun going down and creating a shaft of light here at the top of the painting. I'll move the time on a little further to just before 8 p.m. So the environment now looks good, and next I'll just need to adjust the interior illumination to compensate for the darker environment. And this is just a case of increasing the intensity of some of the lights. Here's the scene now I've made those changes, and I'll just check the image with a larger interactive view before creating an offline render. Aside from the exposure value, I'll leave the settings pretty much as they were for the previous exterior visual. However, this time I'll use the CUDA engine to render via my graphics card, and I'll select the C++ option to use the CPU cores in addition to the GPU. I'll leave the quality setting at medium and turn on the V-Ray denoiser. I'll set the output to be constrained to the viewport proportions and a width of 3000 pixels, and just as before, I'll add some render elements. I'm going to enable light mix, and this is the setting that allows the lights to be adjusted after rendering. And this can be really useful in fine-tuning an interior scene. In the light mix settings, I want to change the group by parameter from individual lights to group instances, so that I have the same control over grouping as in the V-Ray asset editor. I'll now select Render with V-Ray to start the offline render, and I'll skip through the render to get to the completed image in the V-Ray frame buffer. With the render having been completed, I'll now open the light mix settings. Each light or grouping of lights is represented here as an individual parameter with an intensity value, and I can adjust these values or turn individual lights off. So, for example, if I turn off the stairwell illumination here, I'll see the contribution that this makes to the scene. Note also that the denoiser pass will rerun after making changes to the illumination in light mix. I can, of course, also make changes to the intensity of the light and change the colour. If I look at these lights that are further back in the scene, I've called these east wing lights, I can turn these off to check the contribution to the scene and then adjust the intensity accordingly. I don't want to make these too bright, however, as I'll lose the sense of depth in my scene. The self-illumination parameter here is for emissive materials like the TV screen. So, if this is a little bright, I can reduce the intensity here. Although it's almost completely dark outside, there is still some environmental illumination contributing to the scene. And if I turn this off, the trees through the window here will no longer be visible. Another really useful feature of light mix is that once I've seen the final render, I can slightly colorize these circular feature lights, not by the big values I was using earlier, but just, for example, enough to slightly warm the light and make them look less stark. Finally, when I'm happy with any changes, I can save the current channel out as in the other videos, and as before, I'll use a TIFF file format. So that's about the end of what I wanted to cover in this video. Thanks for watching, and please feel free to leave any comments below. If you found this video useful, then please hit the like button, and remember that to keep up with the latest developments in Rhino and V-Ray, then you can subscribe to this channel. At Simply Rhino, we offer training for Rhino and V-Ray, so check out our website for more details. Thanks again for watching, and I'll catch up with you in the next video.